Good morning. Today I'm going to answer your questions. I got a few questions from Melissa and JE, and I'm happy to answer them. I will start with question number 3B on page 578. So page 578, question 3B. So the question says f at t equals log base 3 of log base 2 of t. We need to find, oh, this is h, not h. We need to find h prime of 8. Right. So when we have a question like this, I need to know what rule I have to use. So this is a composite function. We can say that this is f of x and this is g of x. So the derivative will be f prime of g of x times g prime of x. We have to use the chain rule. So h prime of t will be the derivative of this function, disregard what's inside here. So the derivative of log base 3 of anything is 1 over that thing ln the base times the derivative of whatever inside. The derivative of log t base 2 is 1 over t ln 2 times the derivative of t, which is 1. So the answer will be 1 t log base 2 of t ln 3 times ln 2. Then I will substitute with 8 because I need to find h prime of 8, and that will be 1 over 8 log base 2 of 8 ln 3 ln 2. That's 1 over 8 log 8 base 2 means 2 to the power of what equals 8, which is 3 ln 3 ln 2, and I can write this as 1 over 24 ln 3 ln 2. This is the answer. If you want to write it in decimal, you calculate ln 3 using the calculator and ln 2 using the calculator and multiply the denominator and find the answer. But up to here, you get the full mark. Okay, so this is the first question. I need the space here. So we are going to do page 578. The next question is number 4D. Question 4D says y equal 3 to the power of x log x base 3, and we need to differentiate, means we need to find the derivative, or we need to find dy by dx. It is 4D, right? Page 578. Okay, so this is the question. This is two functions multiplied together, so this is the first and this is the second, and we need to apply the product rule. Product rule says first times derivative of the second. Derivative of log x base 3 is 1 over x ln the base times the derivative of x, which is 1, plus the second times the derivative of the first. Derivative of 3 to the power of x is 3 to the power of x ln 3 times the derivative of the function. If there is a function here, it's 1 because it is x. So we can write this as 3 to the power of x over x ln 3 plus 3 to the power of x ln 3 times log x base 3, and we can factor out 3 to the power of x, or we can leave it like that. It doesn't really matter that much, but this is the answer anyway. Okay, so this is 4D. Okay, if you want to do one step further, because 3 to the power of x is common, so that would be 3 to the power of x, 1 over x ln 3 plus ln 3 log x base 3. You can also find the common denominator and add those, but for me, up to here, I'll be very happy. Okay, so this is question 4D. I want to keep track of the time. Next question is question 4E. And the question says y equal 2x log x base 4. Again, this is two functions multiplied together, so we have to use product rule to find the derivative. So y prime will be first times derivative of the second, which is 1 over x ln 4, plus the second times the derivative of the first, which is 2. So this is 2x over x ln 4 plus 2 log x base 4. X and x here cancels out, so this is 2 over ln 4 plus 2 log x base 4, and you can factor the 2 out if you want, or you can leave it this way. We have no problem. ln 4 plus log x base 4. Okay, this is 4E. The next one is 4F. Says y equal log base 5 of 3x squared over the square root of x plus 1. So square root of x plus 1 is the same thing as x plus 1 to the power of 1/2. Don't forget that. Okay. So when we we find y prime, I have to use quotient root, so low squared. When I square something under the square root, the square and the square root cancel out each other, so it will be x plus 1. Low d high, so square root of x plus 1. D high, the derivative of the high is 1 over 3x squared ln 5 times the derivative of whatever inside, which is 6x. Minus high d low. High is log base 5 3x squared. D low, the derivative of the low, derivative of this is 1/2 x plus 1 to the power of negative 1/2 times the derivative of x plus 1, which is 1. Alright, now we try to clean this up a little bit. So y prime will be, I can cancel out this x and this square. So it will be 6 square root of x plus 1 over 3x ln 5 minus 1/2, this 1/2 log 3x squared base 5, and I can send this down and change the sign, send this to the denominator and change sign to be 1/2, and when I change the sign to be 1/2, I can return it back to square root of x plus 1. Everything divided by x plus 1. This is the derivative. Actually, we can, for me, up to this, we can cancel out the 3 and the 6, and that leaves 2. I don't think there's anything else we can cancel. We can multiply everything. We know that dividing by x plus 1 is the same thing as multiplying by 1 over x plus 1. So I can multiply this in here by 1 over x plus 1. So if I multiply this term by 1 over x plus 1, this is, so the 2 stays and x stays and ln 5. This is x plus 1 to the power of 1, and this is x plus 1 to the power of 1/2. So that will leave x plus 1 to the power of 1/2 in the denominator, which is